Okay, let's get going. Number one, the operator of a local mall wants to find out how many of the mall's employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey all 170 employees at each of the larger stores, 50% of the 90 employees of the food court, every employee, or every 30th employee entering each mall entrance for 1 week. We're going to discuss why it's answer choice 4, but it is answer choice 4. That's the way that you would get a random sample out of this. Surveying every employee is not a sample. That's everybody. 50% of the 90 employees in the food court, that's going to be biased because those employees already work in the food court. And all 170 employees at each of the larger stores. Well, what about the smaller stores? What's going on there? So that's not really helping them. So every 30th employee entering each mall entrance for a week, that's going to get you the right sample. Nahian, you can't hear anything. I'm not sure why. Check your, well, you can't hear. Okay, moving on. This one looks familiar. What is the solution set to the equation below? You can either solve this out, or you can just substitute things in. So we're going to do the smart way, and we're just going to substitute things in. First off, you see it equals x, which means that there's no way that it can equal -1. So right away, this is, oh wait, that's not true. Sorry, I'm dealing with the chat. Okay, so we're going to substitute all values in. That would only be true if there was no -1 over here, but actually it still is true, but whatever, we'll substitute everything in anyway. Okay, let's plug in a 1. So we'll do the square root of 1 plus 1 minus 1. Does that equal 1? Well, this is radical 2 minus 1 does not equal 1. So answer choice 1 is not correct. Answer choice 2, 0. Let's see, the square root of 0 plus 1 minus 1. Does that equal 0? Well, this is the square root of 1 minus 1. 1 minus 1 does equal 0. So answer choice 2 is the correct one. As I mentioned before, you're not going to have the negative over here unless this was like a plus something, then maybe, but this isn't it and this isn't it. So it's answer choice 2. For the system shown below, what is the value of z? Let's go through this. We're going to do this in class in a unit coming up, but I'll just show you how it's done. This is like system of equations. So what you want to do is first convert all of these equations so that they have the constant on one side, but that all of the variables are lined up. So we're going to add 2x to this side. So this is going to be 2x plus y, and we're going to leave some space, equals 14. This is 3x, and then minus 4z equals 2, and this is 3x minus y equals 16. So you want to have them all lined up with the x's, the y's, and the z's all lined up. And I'm going to call this equation 1, equation 2, equation 3. They just want to know what the value of z is. So let's see how we can do that. Let me see if I find x, I can plug in x into 2, and that will give me the value of z. So what I'm going to do here is I'm going to do equation 1 plus equation 3, and that's going to give me 2x plus 3x, 5x, y plus negative y, the y's go away, and there is no z, and then it's 16, 14 plus 16 is 30, so x equals 6. By the way, this is now equation 4, so x equals 6. I'm going to sub x equals 6 into equation 2. So you want to be really, really, really neat when you do these because they're often not this simple. So this is going to give me 3 times 6 minus 4z equals 2. 18 minus 4 times z equals 2. Subtract 18 from both sides. Minus 4z equals negative 16. Divide both sides by negative 4. Z equals positive 4. And that's our answer. There's a way to do this in a calculator. I will show you how to do that. And there you go. So you're already done with question 3 on the Regents. Let's see, the hours of daylight. So here we're on question 4. The hours of daylight, Y, that's the number of hours. In Utica, that's in New York. In days, X, so hours of daylight, X represents days. From January 1st, 2013 can be modeled by this equation. Don't be afraid, it's just some equation that is shifted up 12.23, and it's shifted to the right 1.4, and there's some sort of vertical stretch going on here, and then we don't even need to know what this is at the moment. So something's happening here. How many hours of daylight to the nearest tenth does this model predict for February 14th, 2013? Well, what we need to do is substitute in the correct X value. That's the number of days. So this is from January 1st, and they want to know February 14th, Valentine's Day. So there's 30 days, has September, April, June, and November. All the rest have 31. So that means that from the 1st to the 31st, so in January, just in January, there's 31 days. And then we want to go to February 14th, so that's 14 days. So the total number of days is 45 days. So essentially all we need to do is in a calculator, substitute 45 for X. So that's what you're going to want to put in a calculator. Let's do this. Okay, so here's my calculator. So we do 3.06. Oh, I already did it. You can see up there. I'll do it again though. 3.06 sine. So you hit this SIN button. 0.017 times 45 minus 1 12.4 close parentheses plus 12.23 gives us 10.41. They want to know to the nearest tenth, so 10.4 is going to be the answer. Back to the Regents. 10.4 is the answer, and that is answer choice 2. Okay, moving on to number 5. Without doing any math, I should hopefully be able to explain this. A certain pain reliever is taken in 220 milligram doses and has a half-life of 12 hours. What this means, half-life, means that after 12 hours, there's going to be half of the amount that you ingested in your body. So after 12 hours, there's going to be 110 milligrams. After another 12 hours, there's going to be 55 milligrams, so 110 minus divided by 2. After another 12 milligrams, there'll be half of that, and half of that, and half of that, and so forth. This is the function. A is the amount of pain reliever in milligrams remaining in the body after T hours. According to this function, which statement is true? 1, every hour the amount of pain reliever in the body is cut in half. Wrong. Every 12 hours the amount of pain reliever is cut in half. In 12 hours, there is no pain reliever remaining in the body. Wrong. In 12 hours, there's going to be half of this in the body. In 24 hours, there is no pain reliever remaining in the body. No, as we'll see in class, it's going to take days for you to get this out of your body. In 12 hours, 110 milligrams of pain reliever is remaining. Yes, that is the answer. If you just understand what half-life means. Okay, let's move on to number 6. This is a lovely one, he said sarcastically. This expression cannot be rewritten as, well, let's double distribute this out. X times x is x squared plus ax plus bx, so plus ax plus bx and plus ba plus ab. So this is it. It's one way that you can write it. Let's see if that shows up anywhere. All right, so let's just go through these. Let's do 1. Distribute. You get ax plus ba plus x squared plus bx. Let's see, does this match up with what we have over here? You have an ax, you have a ba, ab, same thing, an x squared, and a bx. So 1 is the same. Let's look at 3. Let's FOIL this out or distribute this. This gives us x squared plus ax plus bx plus ab. That's the same thing. So 3 is the same thing. Let's look at 4. This is x squared plus ax plus bx plus ab. 4 is the same, which means this must be wrong. And we'll see, look, x squared, okay, that matches up. AB matches up, but there's no way that you can get an ABX in this thing. The answer cannot be written as, the answer is answer choice 2. Not going to do number 7 because it requires a fundamental understanding of statistics and a calculator, and we're just going to skip this for now. This, believe it or not, is an exponent laws question. So let's do it. So it's saying it can be represented. This is, which is not equivalent. This is just like the other question that we did. You have to find out what is the same and what's not. So let's look at this. Let's distribute this 2.5 through. So we'll get y equals 2.5 minus 2.5 times 2.7 to the negative 0.10x. Is that any of these? 2.5, 2.5 minus 2.5, 2.7. That's this. So this one's okay. Let's take a look at these. We might have to move in reverse. Well, let's just look at this portion. So these are all the same. So we don't care about that. These are all the same sign. We don't care about that. These are all the same. So we only need to really look at this stuff. So let's look at this right here. Let's see. Oh, this is the one that and we already said this one was good. Let's look at this right here. 2.7 squared to the negative 0.5. Well, what happens when you have an exponent raised to an exponent? You multiply them. So you multiply this to this, and this gives you 2.7. Well, 2 times negative 0.5 is negative 0.10. Gives us the x. So this one is the same. You can see right here. Let's see, so this one's good. How about this? 2 point, going back here. Remember what we do when we have a negative exponent, what we can do. 2.7 to the negative 0.10x is the same as 1 over 2.7 to the positive 1.0x. Bam, that's the same. This over here can't be the same, but what you would do is you would add the exponents. They're multiplying these two together. So this would be 2.7 to the negative 2 plus 0.05x, which is 2.7 to the negative 1.5x. Negative 1.5 is not the same as this, so our answer, which one is not correct, is number 4. This is exponent laws, stuff that we did in the first couple weeks of school. Quotient. Okay, polynomial long division problem. Nice and simple. We got 10 x cubed minus 3x squared minus 7x plus 3 divided by 2x minus 1. Let's see. What do I have to multiply 2x by to make it look like a 10x cubed? About a 5x squared. Distribute this. This gives me 10x cubed minus 5x squared. This is a 3. You subtract, which means you just change the signs and add. This gives us a 2x squared here, minus 7x. Let's see, 2x. This will give us plus x, 2x squared, minus x. Change the signs, combine, minus 6x plus 3. Let's see. 2 divided into negative 6 is negative 3. This will give me the minus 6x that I need and the plus 3. Change the signs, combine. You have remainder of 0. 5x squared plus x minus 3. 5x squared plus x minus 3. Answer is choice 4. Okay, Judith puts $5,000 in an investment account with interest compounded continuously. Which approximate annual rate is needed for the account to grow to this much after 30 years? There is a formula that you will learn. A equals PERT, P-E to the R-T. A in this case is 9,110, the total amount. P stands for principal. Principal in investing is the initial amount of money that you invest. E is a constant. It's like pi, so we leave it there. R is what we're solving for. It says which approximate annual rate is needed after 30 years. T is 30. So you just substitute all these things in. Now we're solving for an exponent. This is something that you need to use logarithms to do, but we can do it if you follow along with me and you have an understanding of what an inverse is. So we divide by 5,000. Right, our goal is to get this R alone. Let's see, 9110 divided by 5,000 is 1.822. 1.822 equals E to the 30R. Now the inverse of E to the X, E raised to something, is something called ln. So if I apply its inverse on the right, I have to do the same thing to the left. What this does is it cancels out the inverse. So this goes away, the E goes away as well. So we're left with ln of 1.822 equals 30R. I solve for R by dividing by 30, and I get that my rate is ln 1.822 over 30. So ln, hit it here, ln, let me clear everything, ln 1.822 divided by 30 is 0.019999. We want to get that as a percentage, so we multiply it by 100, and we get 1.999. So let's go back to our answer choices. Remember, that was 1.999, and the closest thing to 1.999 is this over here, 2. So the answer is answer choice 1, 2%. Let's think about what that means. If you invest $5,000 at an interest rate of 2%, after 30 years, you'll have $9,000. That's not very good, but whatever, it's just a Regents problem. Over here, this problem should look familiar. We saw this on the IA. I'll go over it again. You have n equals this, m equals this. What is n over m? Well, that's just this equals a to the 5 halves over a to the 2 halves. which is a to the 5 halves minus 2 halves, or a to the 3 halves, which is the square root of a to the 3rd, right? Because a 2 goes there. Answer choice 4. So there's only 8 of you guys. At any point, if you want to just unmute your device and just ask a question, you can do that. Boy, okay, the solutions to this. This is definitely a quadratic formula situation. Let's see, how are we going to do this? This is kind of what we're doing this week. I'm not sure I want to do this right now. Let's put this entire fraction, let's put this on the other side. And let's subtract 5 to the other side. So x plus 3 minus 5 is x minus 2 equals 4 over x minus 1. Let's see, this is going to be over 1. So we're just going to mute ourselves when we're coming in, guys. Okay. Now we need to give this common denominators. This is literally what we're doing tomorrow. The common denominator is x minus 1, so we multiply this by x minus 1 over x minus 1. So this becomes, I'll multiply this out, x squared minus x minus 2, so minus 3x plus 2 equals 4 over x minus 1 over x minus 1. Once you have common denominators, you can just get rid of them. So now we're left with x squared minus 3x. Let me bring this 4 over. So that's minus 4, so minus 2 equals 0. And I see all these wacky solutions over here, which means I got to use the quadratic formula. So I have a equals 1, b equals negative 3, c equals negative 2. Do I even have room? I'm going to erase all this stuff. And all I really need to know are my a, b, and c values. Okay, let's put it in the quadratic formula. And you get negative b, which is negative negative 3. So that's 3, x equals, plus or minus square root of b squared, that's 9, minus 4ac, minus 4 times 1 times negative 2. So minus 4 times 1 times negative 2 all over 2a, or just 2. 3 plus or minus square root of 9. Negative 4 times negative 2 is positive 8. This is 9 plus 8 all over 2. Radical 17 over 2 over 2. So it's this, 3 over 2 plus or minus radical 17 over 2. There's no i's involved. Okay, going to move on to the next one. This is what we will learn, or some of you guys did learn this last year, maybe forgot. But if this equals this, then t equals, so let me just set this up. A, e is a constant like pi, b to the t equals c. Remember how I said pert? This is p, e, this is r, this is t. So sometimes they call the p an a. We want to solve for t, divide both sides by a. Then you get e to the bt equals c over a. Now you take the inverse of e to the x, which is ln. That gets rid of this. You now have b times t equals ln c over a. Divide both sides by b. T equals ln c over a over b. ln c over a over b. Answer choice 3. All you need to know with this that's different is that if you put an ln in front of an e, it just gets rid of the e. (14). This is a really easy one. For which values of x rounded to the nearest hundredth will x squared minus 9 minus 3 equal log base 3 of x? It looks really difficult. All you need is a calculator. What we're going to do is graph both of these and then find their intersection. Their intersections will be the answers. So we've got, go to math, absolute value. It was x squared minus 9. I like this calculator. It's cool. It shows you right away what's happening. Minus 3. And we want to know where that equals log base 3 of x. Again, I believe you go to math. Log base 3. Put the x there. Okay, and let's go to our graph. Where do they intersect? Somewhere over there. I'm going to zoom in a little bit. Let's try this. This is taking really long, so I'm going to go to Window and change the resolution over here to like 2. That should make it go faster. A little faster. Now what I do is second calc. I'm not doing minimum, I'm not doing maximum, I'm doing intersect. Hit enter. It says first curve, the blue one, yes. Second curve, the red one. Now it says guess. It wants you to put this thing and guess where you think the intersection is. And you can see it's at 2.29. Let's look at the second intersection. Enter, enter, scroll. The first one was 2.29. This is 3.629, 3.63. So 2.29 and 3.63. That's answer choice 1. So this. Okay, moving on to 15, the terminal side of an angle theta. In standard position, intersects the unit circle at this. What is the value of secant theta? You got to give a slight background of this. This is cosine. This is sine. Whenever you see unit circle in these things. So secant theta equals 1 over cosine. There's another thing called cosecant, and that's 1 over sine. Well, cosine is negative 1/3. This is 1 over negative 1/3, which is negative 3. Answer is 1. You could do that in a calculator, or you could keep change flip. You could do 1 over 1 over negative 1 over 3. Keep change flip. Okay, so nice and easy one as long as you know the definition for what secant theta is. What is the equation of the directrix of a parabola with this? Well, let's see. H is 4, negative 4. K is 3, which means the vertex is at negative 4, 3. P-value is negative 2. Negative 1, 2, 3, 4. 1, 2, 3. This is the vertex. The p-value is negative, so this thing goes down. Up another 2 will be the focus. Down 2 from here, which is negative 4, 3, is going to be, I'm sorry, this is the directrix. This is going to be the focus. So the directrix is y equals 5. So 5. Answer choice 1. All right, let's move on. The function below models the average price of gas in a small town. We've got this. What is the absolute maximum over the domain 0 to 10? Well, let's pull up our calculator. We want to find the maximum, so we punch this thing in. Let's see, it is negative 0.0049 t to the 4th, or x to the 4th, plus 0.0923 x to the 3rd minus 0.56 x squared plus 1.166 x plus 3.23. And they want it over the domain 0 to 10. And we'll do zoom 0, zoom fit. Right, so they want that, the peak. I'm going to give myself some room in this. The y I'm going to increase from 4 to like 6. Second, to calc, we're looking at maximum. Go to the left of the peak and hit enter. Go to the right of the peak, hit enter, and then guess where you think the peak is. And the calculator will do the rest. It is at 4.0079. Let's go back. 4.0079. See, 4.0079, that's this, answer choice 3. Okay, this guy here, written in simplest form. We can do this. That looks like a dots on the top. This one's a little tricky, I think, though. So let's do the top. The top is going to be C plus D, C minus D. The bottom, D squared plus CD minus 2C squared. Let's see, D squared plus CD minus 2C squared. There's your D squared. You need a minus 2C squared. So we need a C here, and we need a C here, but it's got to be minus 2. And let's see, we want plus CD. So I'm going to make this plus and minus. Let's see what happens. This gives me D squared minus CD. This gives me plus 2CD and minus 2C squared. Combine this to make D squared plus CD minus 2C squared, which is what we wanted. So we do D plus 2C and D minus C. Does that look like any of our answers? No, not yet. Here's a little trick. D minus C, you can factor out a -1. This can be written as -1 times C plus D, because -1 times C is -C. I'm sorry, C minus D. C minus D. So we're going to rearrange this thing. So it's going to be C plus D, C minus D, all over, we'll factor out that -1, we'll bring it out here. So negative D plus 2C, C minus D. Now we can cancel these, and we're left with, let's see, minus C plus D over D plus 2C. So far, nothing looks like that yet. Let's distribute. This is minus C minus D over D plus 2C minus C. So it is answer choice 3. Got to be really, really, really good with factoring for that one. This remainder theorem, all you have to do is do p of positive 5. That's 2 times 5 to the third minus 3 times 5 plus 5. 2 times 125 minus 15 plus 5. This is 250 minus 10, or 240. Nice and easy one. Do I want to do this? Sure, let's do this. The results of simulating tossing a coin 10 times, recording the number of heads, and repeating this 50 times are shown in the graph below. Based on the results, which statement is false? So 5 heads occurred most often, which is consistent with the theoretical probability of heads. Let's see, did 5 heads occur most often? Yes, and you would expect that 5 heads would occur if you flipped a coin 10 times. Theoretically, 5 times out of 10, it should land on heads. Let's see, 8 heads is unusual. Let me see what they're trying to say there. 8 heads is unusual as it falls outside the middle 95%. Obtaining 3 heads or fewer occurred 28% of the time. Let's check that. So there's 50 of these dots, 50 times. So attaining 3 heads or fewer. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 out of 50 is 28%. So this one's good. 7 heads is not unusual as it falls within the middle 95% of the data. 7 heads is not unusual. Correct. 7 heads wouldn't be unusual. 8 heads is also not unusual. And we'll discuss that why. But if you see 1, 2, 3, 4, 5, 6 over 50 is a decent percentage. It's not less than 2.5. So 8 heads is actually common. You could expect that to happen. So the answer here, the false one, is 2. 21, what is the inverse? And do this one really quick. Let's see, we'll divide. So you do y equals -6, x minus 2. Change the y's and x's. Y minus 2. You can distribute this. Subtract 12 from both sides. Divide both sides by -6. Change y to f inverse notation. -x over 6 plus 2. Answer is choice 2. Let's see. Brian deposited 1 cent into a non-interest-bearing bank account on the first day of the month. He then additionally deposited 3 cents on the second day, 9 cents on the third, and 20 cents. Okay, so what would be the total amount? So he deposited day 1, 0.01, day 2, 3 cents, day 3, 9 cents. We want to know the total. So what would be the total amount of money in the account at the end of the 28th day. So we just got to keep doing this 20 times. He's multiplying this every single time by 3. You could see to go from 0.1 to 0.3, he did times 3. Here he did times 3. And there is a formula for this. It's in the very end in the reference table. It is A1 minus here. A1 minus A1 R to the N, 1 minus R. We're almost done with multiple choice. So it's A1. I'll explain what these things mean. A1 is the initial amount. So it's A1 minus A1 R to the N over 1 minus R. A1 is the initial amount. That's 1 cent minus A1 again. R is the multiple. I told you that he was multiplying it by 3 each time. And then N is the number of times. N is 20. Over 1 minus 3. Let's see, you do this out. Pull up the calculator. So we do 0.01 minus 0.01 times 3 to the 20th. And that whole thing divided by 1 minus 3 is 174,33922. 174,33922. So it's answer choice 2. The 3 stands for the common ratio. The 3 is the common ratio. It's how much you're multiplying it by each time. So again, we went like from, if you go to like 1 to 3, we went 1 cent to 3 cents to 9 to 27, right? So to 81. So each time you're multiplying it by 3 times 3 times 3. That's how you're getting there. You could go to 4 to 12 to 36. In this situation, you're also multiplying by 3. This is called a geometric series, which we will do. Let's see. If this function represents exponential growth, which statement must be true? A and B have to be greater than 1. Oh, so which is false? 1 is true. Let's see. I'll just show you what an exponential growth function looks like. It looks like this. So it grows very fast, and it never touches the x-axis. It goes through a point here. So let's see. The asymptote, that's the thing that it doesn't touch, is y equals 0. Y equals 0 is this, is the x-axis. That's true. never touches the x-axis. An asymptote is a line that a function never touches. The y-intercept is 0a. Yes, because just plug in 0. Remember, this is x, this is y. Let's plug in zeros. G of 0 equals a b to the 0. B to the 0 is just 1. This is a times 1. So this is a. Right? So this is true. The x-intercept, this is false. There is no x-intercept. This thing will never go through the x-axis. Unless it was shifted down somehow, but it's not shifted down. Okay, at her job, Pat earns $25,000 for the first year and receives a raise of $1,000 each year. The explicit formula for the nth term of this sequence is, so like for her 5th year, for her 100th year, that's what n represents. Is this, which rule best represents the equivalent recursive formula? So this is saying that she gets 25,000, K, and then the next year she gets 25,000 plus 1,000, and then the next year she gets 25,000 plus another 1,000. So she gets this plus another 1,000. The next year she gets 25,000. She gets what she had the year before plus another 1,000. So she always gets what she had the year before plus another 1,000. This is explicit. This is an explicit formula. This is saying that you start with 25,000, and then the next one is going to be, this means the one before. So if you're looking for the third one, you look at the second one and then add 1,000. Over here we had the third one is the same as the second one, then adding 1,000. So your answer is going to be choice 3. Again, we will learn more about that. But a couple of you already took this class, so hopefully that rings a bell. Okay, we can all do this. Elizabeth trying to find the product. Her work is shown below. Identify the error and determine the product. Let's see what she do here. 6. What is Elizabeth doing? So she did 2 times 3, which is 6. That's good. 2 times negative I is negative 2i. That's good. 4i times 3 is plus 12i. And this is minus 4i squared. This step's good. Let's see. She combines these to get 12i minus 2 is 10i. This step's good. She converts I squared into 1. That is not good. This is the mistake right here. So you would say I squared equals negative 1, not positive 1. So that's her mistake. And then correctly determine it. Well, we'll do 6 plus 10i, and we'll just start from where her mistake was. Minus 4 times negative 1. 6 plus 10i plus 4. 6 plus 4, 10 plus 10i is the answer. That's something you guys could do right now. Let's see. A runner is using a 9-week training app to prepare for a fun run. The table below represents the amount of the program completed and the distance covered in a session. Based on these data, write an exponential regression equation rounded to the nearest thousandth to model the distance the runner is able to complete. What you do is you take your calculator on this one. I'll show you exactly what to do. Let me pull the calculator up. Okay. So you go to stat. So we're doing, you go to edit. When you have these lists here. So the first list, you're going to put all of the first values. So we had 4/9. I can see it. I know you guys can't see it, but the next one was 5/9 of the way, then 6/9 of the way, then 8/9 of the way, and then finally 9/9 of the way. And what they're saying is that when he ran 0.4 miles, he did it in, I'm sorry, the 4th week, he was able to run 2 miles. The 5th week, he ran 2 miles as well. The 6th week, he ran 2.25 miles. 8th week, he ran 3 miles. And the 9th week, he ran 3.25 miles. Once you have this in here, you go to stat, calc. It says exponential regression. So you've done linear regressions in Algebra 1. Exponential regression. Go to calculate, and you get y equals a times b to the x. So it's 1.223 times 2.652 to the x. Let's go back. 1.223, 2.652. And that's what you would write. You would have to write y equals 1.223 to the nearest thousandth. So 1.22. No, I had it right. 1.223 times 2.652 to the x. That's the answer. They want you to write an equation. Okay, formula for work. Let's see, Fred and Barney are carpenters who build the same model desk. It takes Fred 8 hours to build the desk. It takes Barney 6 hours. Write an equation that can be used to find the time it would take both carpenters working together to build a test. So T1, the time it takes the first person to complete a job. Well, that's 8 hours. T2, the time it takes the second person, that's 6. So we have 1/8 plus, just use what's given to you, 1/6 equals 1 over the total. This is what they want to know. Let's see, 8/6, 1/8, 8, 16, 24. So this is 3 plus 4 over 24 equals 1 over total build time. So 7/24 equals 1 over the total build time. Let's cross multiply here. So we get 7 TB equals 24. And the answer is 24/7. They want it to the nearest tenth of an hour. 24 divided by 7 is 3.4. So it's going to take them 3.4 hours to build a desk if they're working together. So what I did there is I just looked at the formula and I just substituted the things that are in the formula. Nothing too crazy. Completely factor. This is a good one. You guys can do this. We're going to try grouping, obviously. There's 4 terms. Let's see here. We can factor out an x. So we'd get x plus 3y. And then we go here. There's no common factor. So this isn't working. What we're going to do now, though, is you can rearrange this original expression. So we're going to put the x squared plus the 3x squared next to each other. We're going to have 3xy plus y, they're going to be next to each other. That's the commutative property of addition, allows you to do that. Now let's do grouping and see if it works. Factor out an x squared, we get 1 plus 3. Here we factor out a y, we get this is to the third, 1 plus 3x. Here we get 3x plus 1. 1 plus 3x and 3x plus 1 are the same thing. So we do 3x plus 1 times x squared plus y. Final answer. All right. This, you need to know how to create these equations, and I'll show you right now. Researchers in a local area found that the population of rabbits with an initial population of 20, so the initial population of 20, grew continuously, so we put the E, at a rate of 5% per month, so 0.05 per month. So, and this is the population of rabbits, so do rabbit per month. The fox population had a value of 30, so the fox per month was 30, grew continuously at a rate of 0.03 per month. How long does it take for these populations to be equal? What we do in this situation is use a calculator. Go here, we plug both of our formulas in. One was, I think, 20 times 20 e raised to the 0.05 x, and the other was 30. Second ln gives me e to the x, 0.03 x. See, this one starts off with less, but it's growing faster. This one starts off with more, but it's growing slower. So let's see. Let's graph these. Oops, go to. Remember, I was zoomed in before, so this isn't going to be good. So I'm going to go to zoom. Zoom standard. No, that was zoom trig. I don't know why this is taking so long. Anyway, it's unfortunate that's not working because there's a lot of questions like this. What you're going to do is you're going to see two graphs like this, and then you go to second calc, and then you do intersect, and then you guess there, and that tells you the answer. And then you just have to write here, calculator, intersect is, and then you would just write whatever those numbers are. Let's see, consider this function. Not going to go into this. The answer is q of x, though. Let's do one that we all know how to do. Here we go. The zeros of a quartic polynomial. So draw it, plot the zeros, -1, -2, 2, and 3. And that's your answer. Or you can go the other way, because they don't mention whether or not it had a negative or a positive leading coefficient. So it's going to be something like that or something like that. Explain, we did this on the IA, but what you want to say is the denominator is the radicand, so and the fourth root of 81 is 3, and 3 to the third is 27. This one was on the IA. Not going to do it. This is a probability one. This one's really important if you're planning on trying to do well in January. Let me show you this formula. It's the probability of A or B equals the probability of event A plus the probability of event B minus the probability of events A and B. Okay. It says the probability that a student selects math as his favorite subject is 1/4. Probability a student is a junior is 1/16 over 459. If the probability that the student selected is a junior or chooses math is 47 over 103 over 108. 47 over 108. What is the exact probability that the student is selected is a junior whose favorite subject is math? That's the same thing as saying probability of A and B. So we're solving now for X, for something. So you could use your calculator in all of this. And essentially what you want to do is just 47 over 108 minus 1/4 minus 1/16 over 459 equals X equals negative X. So multiply both sides, find what x is, and then just unnegate it, essentially. Or you can rewrite it as x equals negative 47 over 108 plus 1/4 plus 116 over 459. Are the events the student is a junior and the student's favorite subject is math independent of one another? There's a test for independence. So if independent, then probability of A times the probability of B equals the probability of A and B. So what you would show is that the probability of A, which is 1/4, times the probability of B, 116 over 459, you would show that that doesn't equal whatever that X value is that you got up there. And that's the answer. Almost done with this test, I hope. Not going to do that. Over here, this is a good one. You guys could definitely do this if you see this in January. The function has a leading coefficient of 1. Write an equation. Well, what are its zeros? Right, its zeros are -4, 0, and 3, which means we could write this as f of x equals x plus 4, x plus 0, x minus 3, and that's sufficient. So that's it. That's the answer. It says that it's translated f left 2 units. So we want to translate this function and write a new function, g of x, that's translated left 2 units. Well, how are we going to do that? We're going to, right, we add 2 to both, to each of these. So g of x is going to be x plus 6. Right, left, you go the opposite. X plus 2, x minus 1. That's the answer. That's it. This is the last one. I'll go through this very briefly. I'll give you a quick background on this problem. They want you just to graph this thing. Okay, the way you graph this isn't with a graphing calculator. It's using your knowledge of what we're going to learn. So essentially, this 120 over here is going to represent a line. So this would be 90, 100, 110, 120, 130, 140, 150. What you do is you just draw a line like this at the 120 mark. Now this says cos, and this 24 means that this function is going to go up 24. So 120 plus 24, 24. It's going to go here, and it's going to go down. So it's going to oscillate between there, and it's going to go down 24. And like there. So it's going to exist in this area. And now there's this thing, it's fp equals 2 pi. It's this formula. P is f is this, 3 pi. It's the thing in front of the variable. So now you do 3 pi times p equals 2 pi. To get p, divide both by 3 pi. So you hear p is 2/3, which means that this function is going to repeat 3 times every 2 seconds. What does that mean? This is 2. So it starts up here, and again, we'll practice graphing these. Right now my computer's really acting up. But let's see, 1, 2, 3. Means you have to split this interval into thirds. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So every 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this function is going to go down to here and then back up. Once you have all this stuff, it's actually not that hard. You go down, you go up, and that's one piece of the function. Then it goes down, it goes back up, and then it goes down, and it goes back up. And this would get you full credit, as messy as it is. There's a lot of really, really, really good delta math stuff that just has you practicing graphing these. And then it says over here, determine the period. I determined earlier that the period for this P was 2/3. That means that every 2 seconds, the heart, I guess, beats 3 times, something like that. And it says normal resting blood pressure for an adult is 120/80. That would mean that 120 is the highest and 80 is the lowest. Adults with high blood pressure, blah, 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 may be at risk. Classify the given patient's blood pressure as low, normal, or high. Well, I think he started at 120, so he would have high blood pressure because he started at 120. Let's go back up. Yeah, this guy's blood pressure started at 120 and went up and then down. So we'd say that he has high blood pressure. All right, that's it for this Regents. Rewatch this. Thank you for the 4 people that stuck it out. Appreciate you guys. I'll see you tomorrow.